In this Matlab tutorial, we'll be starting to generate data, manipulate data, and look for points of interest in 1D images. Suppose we have a list of numbers and that we are interested in a particular value and would like to find where in the list it occurs. We can use logical expressions and search this vector for the number we are looking for, and then when we find it, we can print the location out. For example, suppose we have this vector here, 9, 11, 2, 10, 7. If we're looking for the number 11, we can clearly see that the number 11 appears in the second location. But we'll use Matlab to automate this process for much larger data than this. Automating this simple case is an important first step to automating finding Wally in a large image. In this tutorial, we'll be sorting through lists of numbers called vectors in Matlab, and we'll start to use for loops, logical expressions, and learn about different ways to index variables in Matlab. All of the new functions we'll encounter are listed here on the right. The first thing we'll do is generate test data for analysis. We'll use for loops and logical expressions to search through it for our number of interest. Then we'll report that result to the command window and plot the results. Let's move over to Matlab and get started. I'm not going to go through this in every tutorial, but just to refresh your memory from tutorial 1, I'm going to start with this at the top of every script to clear the console. And I'm going to start up with, and I'm going to have clear there to clear all the variables in the workspace. I've set up all this plotting code here that we figured out in the last tutorial. And in this tutorial, we're interested in finding a particular number, in this case 120, in a vector of test numbers, or a 1D image if you like. And later on we'll do this in 2D images, and then we'll extend this even further to finding Wally. But this is where we're going to start, and we're going to start simple. Okay, let's start by making some fake data. And we want this to be somewhat random. We don't want to just start typing out numbers like 1 and 10, and Matlab's got functions for generating random numbers. And we're gonna use one of them. First MATLAB function for generating random numbers we're gonna use is called randy. It's for generating random integers. So for example, we can tell it we want to generate a random number between 0 and 10, and it'll give us a random number between 0 and 10. A random integer between 0 and 10. We can also generate random vectors with it. We can go rand e. We want them to be between 0 and 10, and we want it a row of 5. So let's do that here. We'll use much larger ranges though. We'll use the range 0 to 119. And we'll do a row of 5. How does that look? We've got a row of 5 random numbers between 0 and 119. And then let's tack 120 in the middle, our number of interest. And let's do the same thing here, randy. And this time we'll go from 121 to, I've got to put this in square brackets. We'll go from 121 to 255. Again, we want a row of 5. How does that look? That's what we want. And every time we call this, we're going to get a different result. This can be kind of frustrating when you're trying to write code for the first time and see whether it's working or not. Sometimes it's nice, even though you want your data to be random, it can be nice to get the same result. So what we can do is we can tell Matlab that when it generates random numbers, we want these so-called random numbers to be the same. So what we can do is we can set something that's called the random number seed. Matlab's function for this is called RNG. And any help documentation for any of Matlab's random number functions will point you in the direction of this function as well. So now if we call this again, we should get the same result every time. I'm just making things a little bit easier to debug. For simplicity, let's store the length of this variable in n. There we go, it's 11 long, and we knew that because we got 5 plus 1 plus 5. We're after the number 120, but we know it's always going to be in the middle. This is by design. Every time we generate one of these, 120 is always going to be right in the middle. But later on we'll come back and we'll randomize the order of these numbers and make sure that it still works. So let's put a comment here so we remember to do that. To do randomize order. Okay. We've got some random data that represents a so-called image, but it's not quite an image yet. Images don't deal with doubles, which are floating point numbers that can represent decimals and whole numbers. Image data is integers. So that was the exact reason we called Randy, because we wanted integers. So let's go ahead and let's tell MATLAB that we want this to be integers. We really want to make it as close to a real image, as working with a real image as we can. So what we can do is we can call uint8. This stands for unsigned integer 8. So this can represent numbers between 0 and 255, just like data from a normal image. So all we have to do is call uint8 with data. And now MATLAB knows these are no longer doubles, but these are integers. So let's call this imData. Well, now that we've got our fake data, let's go ahead and plot it. Let's go ahead and use the function that we learnt last time. Let's go ahead and open up a figure, figure 1, and we'll also clear the figure. Let's use imShow, just like we used last time. There we go. Now, you can barely see it, but right in the middle there is our image data. Now it's plotting that small because it's only 11 pixels wide. So what we need to do is tell this function that we want it to plot as big as the window. So magnification, we want it to fit the window. Now if you want to know where to find this information and other things you can do to this function, all you've got to do is go help imShow. And if you can't see the help you need there, you just click on documentation and it takes you to the documentation page. I'll leave that up to you. Let's give it some labels. We use the same labels we did last time. This is going to be the U axis and its units are pixels. And we're also going to have the Y axis labeled V and its units are also pixels. There just happens to only be one of them. Let's give it a title. This is our 1D image. Now, since this is only a 1D image, it's a row vector, we can visualize it in other ways that make it a little bit easier. So let's open up a new figure, figure 2. Let's clear the figure. And all CLF does is just clears everything in the window, just to keep things clean. We're going to display a bar plot just using the function bar, and we can just simply give it the imData. How does that look? And we get a bar chart. And we can make this look a little bit more interesting. We can call RNG with any number here. Let's give this plot some axis labels. Call X label again. Let's call this is again the pixels. But this is like looking at a cross section. So the Y label is no longer pixels. It's now the height of the particular pixel. If this was an image, it would be called image intensity. We'll give it a title. It's the same thing. It's just plotted in a different way. 1D image. Okay. Suppose we weren't just interested in finding finding the pixel that's exactly 120. Let's say we wanted to find some other things, like we can find the mean, or we can find the max value, the maximum valued pixel. We can use the Matlab function called mean to find the average of some data. So if we just call this with imData, we get the mean value of this vector. Let's call this mean value, mean v for value. And we can also, let's say we're interested in finding the maximum value. Matlab's got a function called max, which if you give it some data, let's call max imData, tell us that the largest value there is 193, which if we have a look, it is. But the Matlab function max actually has two outputs. This is the first function we've seen with two outputs. So the first output tells you the maximum value, and the second output tells you where in the data it is. So if we call, let's call it max value, max v for value, and max I for max index. We call max with imData. Let's see what we get. It tells us correctly that the maximum value is 193 and that it's located in the 11th spot. So we go 11, 193. If we want to display this information to the user, we can print it out here in the console. Matlab's got a couple of functions for this. One's called disp, which simply works like this. And it's got one called fprintf, which works very similarly, but will also allow you to print out formatted data. So let's use fprintf. Fprintf, I'll type in a string here. Let's say mean value is, and it's just coincidence that this happens to be an integer. Actually, let's just change this, RNG0. And we can notice here that it hasn't put a new line there. If we can continue to call this, it's not printing a new line. It's only printing a new line after it calls the command. So if we put a new line there we go. You can see it's dropped in a new line there. If it's put in quite a few decimal points, we can make Matlab restrict this by going, instead of just calling %f, we can say %.2f for 2 decimal points. There we go. Now I've only got 2 decimal points. Let's use fprintf again for printing out the maximum value. And we'll print out where we found it. Now our location is always an integer, so we can use %d or %i. There we go, and we better put in a new line there. And actually, we know that these are always going to be integers, so we can call %d there as well. Let's say we want it to line up with the line above. We can say that we want four characters wide, and if the number's only 3 characters, in this case 251 is only 3 characters, it'll pad it with an extra bit of white space. So now the comma here lines up with the decimal point there. Okay, now we've got all that out of the way, let's actually go ahead and find the number 120. First of all, we're going to go ahead and find it with a for loop. So the easiest way to think about this is, if we don't know where in this image the number 120 is, we can start the first pixel, we can check if it's equal to 120, and then we can move on to the next one and check if that's 120. And as soon as we find one that is, we store where it is. So the way we do a for loop in Matlab is we go for, and then a variable that counts. In this case, let's call it I, and it's going to start at 1, and it's going to go all the way up to the size of this vector, which is n. And then we put end at the end of the for loop, and then we can start looping through it. So for example, we could just display the value that we're on. This would be imData I. If we run this, every time through the loop, we're just printing the number we're at. But that's not very useful. Let's go ahead and let's say if the number we're at exactly equals 120, let's store where it is. Now, if imData I, the one we're up to, exactly equals our number of interest, which we stored in a variable num interest, let's end this for loop. We want to store the location that it's at, which is just the variable I. Let's run this. Now location should tell us where 120 is in this image, and it's at 6, which we knew. We can display this more visually. Let's set a variable. Let's make a variable called occupied, and let's make that just be a vector of zeros, and then whenever we find the number we're after, we'll set it to 1, just so we've got something nicer to plot. Now if we want to make an array of zeros, Matlab has a function for that called zeros. We want a 1 by n array of zeros. Then what we do when we find what we're after, we can call occupied I equals 1. Let's go and have a look at this. We get zeros everywhere and then we get 1 exactly where our number is. Now if we want to display it, we can open up another figure, figure 3. We'll clear the figure again just to keep things neat, just in case it's got something in there. We can let's call bar again just to display it. So let's call bar, and we'll call it with occupied. And that worked. It's just this isn't a very exciting plot. So what you can do is you can use the function called dAspect, which stands for data aspect, to set the aspect ratio of each axis of the plot. In this case, let's just use 1, 1, 1. And now 1 on the y-axis is the same width as 1 on the x-axis. Let's go and give it some labels again. Okay, so we found that with a for loop. And let's plot those. There is a better way to do this. Find pixel with indexing. So we're going to use logical indexing in Matlab now. This is much simpler. So let's say we wanted to find all the values in our data above 200. We can go imData greater than 200. Now it'll put a 1 everywhere that the data is above 200. And there it is. These two are the only ones above 200. If we wanted to find the indexes of the ones that are above 200, we can call find imData greater than 200. It'll tell us that the 10th and the 11th spot are greater than 200. We could do the same thing if we wanted to find all the bits that were less than 50. Only the 3rd spot. We can also do this if we want to find the bits of our image that are exactly equal to 120. And it's element 6, which we knew since we made the data. So let's go ahead and we'll use the same we'll use the same variables, occupied and location, that we used before. So we can call occupied equals imData exactly equal to 120. Brackets are there, just there so we don't get it confused with the equal sign there. If we run this, we get zeros everywhere except for the center, which is where the data exactly equals 120. Now we can use the function we used before called find. We can call location equals find imData exactly equal to 120. I shouldn't have used 120 because we have a variable for that. It's called numInterest. Let's see what we get now. Now we get the location is 6, which is exactly what we got before, just with a different method. The other thing that is worth pointing out is that calling this is equivalent to calling this. We get the same result. Okay, and then we can plot the exact same plot we found before, but we'll use figure 4, and we'll call it found 120 with indexing. There we go. So we're all done, except that even if we go ahead and change this random seed so that we're no longer making our data the same every time we call this, the number we're trying to find is always going to be right in the middle. So what we can do is we can complete this to-do we left up here. We can randomize the order. And MATLAB's got a function called randperm, which randperm, let's give it n. All the numbers from 1 to 11 are here, but their order is now randomized. So we can use this function to randomize the order of our data. Let's call our variable IDX for index, and we're going to call randperm. I'm going to call this with the length of our vector n, just as we did down in the command window. And now we're going to say data equals data, give this our index variable. Now if we do this, we get the same data as before, but the order is now randomized. So now I've completed this to-do, so we'll cross that out. If we call run, now we should get our data, the number of interest we want, in a different spot every time. Okay, that concludes this MATLAB tutorial. Stick around and next time we'll extend this a bit further, and then we'll keep sticking with it and we'll work towards Where's Wally?